The following is the video solution from JSDT Solutions. Question 5.1 says, in the diagram, OP is given with P being -3 and -4, and then we have KOP is equal to A. Okay, so without using a calculator, determine the value of cos A. So we first need to find the other side that is missing. So we're going to draw a line to the x-axis, and remember that this line is perpendicular to the x-axis. So this is your x value and that is your y value, meaning the x value, for you to have gotten that point, you went from here and you said -3 and then -4. So this is -3 over here and this is -4. So all we need to find is OP, okay, which is the hypotenuse. So we can go ahead and find that by saying OP squared is equal to, and using the theorem of Pythagoras, it's the longest side, okay, it's the hypotenuse, so we'll say -4 squared plus -3 squared, and therefore OP squared equals, that's going to be 16 plus 9, which gives you 25, so 25, and then we square root both hand sides. When we square root both hand sides immediately, remember, you have to include the positive and negative solution. You have to consider those. But OP is a length, okay? It's a radius, so it's a length. So OP is always positive, meaning OP equals 5 units. And now we can find cos A, because we know this is 5. So cos is, using SOHCAHTOA, the directions we're going to go is adjacent over hypotenuse. So cos A is equal to the adjacent side, adjacent this angle would be -3 over 5. So that is -3 over 5, and that is our answer. Question 5.1.2 says we have to find the value of cos 2A. So cos 2A, we need some sort of double angle expansion for this. Now choose one that would be simpler. Do you see that you have cos A already? So just choose one with cos A so you don't have to find any extra thing. So we'll say cos 2A is equal to, and we can change it to cos squared A minus 1. Okay, so cos 2A equals 2, and then we are inputting cos A, which is -3 over 5, -3 over 5, all squared minus 1. Okay, and let's just find the value of that. And that is equal to -7 over 25. And that is the answer for 5.1.2. And then 5.1.3 says, find sine A minus B if it's given that sine B is equal to 4 over 5 and B is greater than 90 degrees but less than 360 degrees. Okay, let's find where this is. Now also note that the radius, okay, because that's the hypotenuse, sine is opposite over hypotenuse. The hypotenuse is also 5, just like the hypotenuse in the diagram that we have. So let's go ahead and find this. Sine is 4 over 5, meaning that sine is a positive number. So sine is positive in that quadrant, and it goes from 90 degrees to 360. So sine is positive in the first and the second quadrant. But since this goes from 90 degrees to 360 degrees, then it means it is in the second quadrant. So we have a radius that will be there, and its radius is 5 units. Okay, and we can see that the opposite side is 4. Okay, so it fits perfectly with this one. Okay, because you have those two sides equal, then this is 4. Okay, so that just goes -4 and that's +4. It means that they have a common adjacent side, which is -3. If you use Pythagoras again, you get the same thing since you're using 5 and 4. Two sides are already equal there. Okay, but now we have B. This is not A anymore, this is B. Okay, so we have the diagram down, and then finding sine A minus B should not be a problem. Okay, sine A minus B. What can we use to expand this? Because we don't know what their angles are. We can use the compound angle formula's expansion for this. So this is going to be sine A cos B, and then the sine stays the same. Cos A sine B. Okay, so we're just substituting. What is sine A? Okay, we don't have it here, but it is here. So the opposite over the hypotenuse. So of A, which is the diagram we already had. So that would be over here, sine negative 4 over 5. Okay, so that is negative 4 over 5 multiplied by cos B, which we don't have here, but if sine B is 4 over 5, then cos B is negative 3 over 5, because the other side that we had was negative 3. Then minus, so these two are together and they multiply, minus, and we have cos A. Cos A is negative 3 over 5. Okay, negative 3 over 5. And then we'll put that down as well. Negative 3 over 5. And then sine B, which we already have here. It's 4 over 5. So multiply by sine B, 4 over 5. And we just have to multiply those and get our answer. Okay, but from this we can already see these will be positive. It becomes 12. So 12 over 25 minus a negative, also 12 over 25, same thing. Okay, but it's negative 12 over 25, so that just becomes a plus 12 over 25. 12 plus 12 is 24, so the final answer is simply just 24 over 25, and that is our answer. Question 5.2 says, if cos alpha is equal to P, express the following in terms of P. Okay, so you see that what we have is cos alpha over 2 minus 45 degrees, sine alpha over 2 minus 45 degrees. So we have a repetition of the angles here, which is good. Now, do you see that this looks a lot like the double angle expansion for sine 2a? The double angle expansion for sine 2a looks like this. It says 2 sine a cos a. So it has that sine of an angle cos of the same angle flow. Okay, here we can see that. So we can just make sure that sine A and cos A are the subject. If you did that, you would have to divide both hand sides by 2. If you divide this by 2, you end up with sine 2A over 2. And we can just use that here. Okay, so here in place of cos alpha over 2 minus 45 degrees, we can say that that is just equal to sine 2, and then our A is the angle that was repeated. So that's sine 2 times alpha over 2 minus 45 degrees. Okay, and that goes over 2. Now we still have that. So this is just this part. And then we're still dividing by 2. So we can divide by 2 like this instead. If you say divided by 2, okay, it's dividing by 2 over 1. So we can use the rule tip and times, meaning you change the division to a multiplication and you swap the numerator and denominator. So this is what we have. So this is equal to, and we'll have sine, and we can distribute here because this is the number that multiplies into the angle. So this is going to be sine, and those multiply and become alpha, and those multiply and become negative 90 degrees over, and you see that it's just numerator times numerator, denominator times denominator, so that becomes over 4. Okay, so this is what we have, and our goal is really just to get a cos alpha, because that's the only thing we can express as P. We have negative cofunctions here. So I'm just going to work on this on the side, just so that you can see what it expands to. You can, however, study what the expansions of negative cofunctions would look like. So this is really sine of alpha minus 90 degrees. And how we expand this is you don't just take out the negative and say it's just going to change. That can be very dangerous for certain functions that you work on here. So what actually happens is, because our angle is ultimately negative, okay, because this represents an acute angle, and then you have minus 90 degrees. So it's ultimately negative. And what we do when an angle is negative is we add 360 degrees to make it positive so we can better understand it and simplify it. So this would be equal to sine, and you know that 360 minus 90 is 270. So now you have 270 degrees and still a positive alpha. Okay, so this is what we have. Now, to simplify this, what we can do is it still has a 90 degrees. So we're still using cofunctions. We won't forget that this is still using cofunctions. So we'll rewrite it like this. Sine, and we'll separate 270 degrees as 90 degrees plus 180 degrees. That's what gives you 270, and then plus alpha. Okay, so now that it looks like this, you can group these two together. So if we group them together, this now becomes, we are looking at it as sine of 90 degrees plus an angle. When we say sine 90 degrees plus an angle, this ends up being cos A, okay, of that angle. So this is going to be using cofunctions. So cos of that angle, which is 180 degrees, plus alpha. And if you simplify this using your reductions, this becomes negative cos alpha, since 180 degrees plus alpha is in tan's quadrant. So do you see how that becomes negative cos of alpha? So we don't have to actually write all of that, because that is a rule that you should know by memory. So that is negative cos alpha over 4. And remember, they told us what cos alpha was. It is equal to P. So in place of cos alpha, we'll input P. So this is actually negative P over 4. And that is our answer.